Hi everyone, my name is Kunal Vyas. I am pursuing a course in Coursera called AI Product Management, and within that course, there is a first module called Machine Learning Foundation for project managers. And on the back of that, there is a course project which I need to complete. So I'm just going to present that case here in this video. Now, as we go along, the summary of the project is build a model to predict the electrical energy output in the form of PE of a combined cycle power plant, which uses a combination of gas turbines, steam turbines, and a heat recovery system generators to generate the power. There are specifically 5 objectives which I need to address within this exercise. To begin with, the first objective is type of machine learning, which I would be considering. Now, based on the information and the case study what we have been given, where there are hourly 9,500 observations, and the target variable we are predicting is the power output, which is called PE. And since we are predicting the continuous numerical value, this is a supervised regression problem. To evaluate performance, I chose RMSE, which is root mean squared error, because it penalizes large errors and it is expressed in the same units as the output, right? So let's move on to the objective 2, where I have been asked to determine the possible features to use and identify preferred algorithm. Here in this case, I have considered all independent variables, which are temperature, exhaust vacuum, ambient pressure, and relative humidity, which are represented in order by TeV and AP and RH. And I've used linear regression using the training data with actual PE as the dependent variable and the 4 environmental features which I've highlighted just about TeV and AP and RH as independent variables. And this I've used in my Excel. So let me just quickly show you here. And I've run through the data analysis pack. I've run the regression output, and that's the summary output. And I've used it here to calculate my predictive value. As you can see, all the 4 independent variables have been considered in that values calculation. And let's move on. And there are 2 models I have created. I will come to that on why. So to determine the validation strategy is the purpose why I've created 2 models. And before I do that, I've split the data into 80% training and 20% test set using a random assignment in the formula, in Excel. So it's a very straightforward. I calculate the error for each prediction and squared those errors to evaluate performance, which was required. And I use the Excel formulas, to calculate the RMSE for the test set. And then I've compared for model A and model B. So let me show you that. So this is model A's RMSE. And now when we look at model output 2, as you can see that there are only one independent variable has been removed, which is AP. I've just grayed out. So if you look at the predicted P, you would see that the AP is not been considered, and as a result, the RMSE uh, uh, value is looking quite high compared to the model A. I'll come to that. So I have highlighted what is the RMSE value for model A, which included all the independent variables. And in terms of the validation approach to compare both the models, I had removed the AP as an ambient pressure from that. And as you can see that both the Excel spreadsheet are compared here, and where it shows in the yellow, the numbers in terms of for model A looks much better and lower, and that gives a confidence that the model fit is good. Now, it also, to evaluate the overall final model performance, I created a scatter plot comparing actual versus predicted versus actual power output for the test set. Ideally, the points would all along the diagonal line, and as we can see in bottom graph, the predictions generally follow the actual value closely compared to model B, where we have excluded one of the independent variable, and as a result, it looks quite change, and clearly we can see that the model A has a better fit. So the conclusion is I have successfully built a regression model in Excel to predict energy output using environmental data, which was provided in the dataset, and the RMSE metric and the scatter plot shows that the model performance reasonably performs well in this use case. Thank you.